In this last step, I want to consider the special problems and features associated with binary files. Now, in a sense, all files on disk can be treated as binary because they're all ultimately composed of bits, that is, binary digital information. But text files are treated specially. Text files are files that contain human-readable text, the sort of text you can load into an ordinary notepad application on your computer, and which end with line feeds or carriage returns, so they are convenient to process in a special way. But there are other sorts of binary files that don't contain that sort of data, and for example, in the programs that I'm going to be looking at in this step, I want to save my CD database, my CD records onto disk. Well, a CD is not an ordinary text piece of data. Each CD contains both strings and numbers and integers, so they have to be treated specially. Let me show an example of treating a text file as a binary file. You can find this in 01_read file. That's the project in the step 10 part of the code archive. Now here you can see I have a text file called sonic.txt. It's the same text file I've used in previous examples. And when I run this code, I open it in binary mode, RB, where B indicates binary. But instead of processing the contents of this file one line at a time, as I did in the last step, this time I read the entire file into memory and process it one character at a time. Essentially what I do is I fill an array or a buffer, B, with the contents of the file. And I iterate over the characters and increment a variable line count each time the new line character /n is found. But that isn't the interesting part of this program. The really interesting element is how I calculate the size of the buffer needed to hold the contents of the file. After all, I don't know in advance how big the file will be, so I can't declare a fixed size array in my code, because the size might be wrong. Let's look how this is done in some detail. Bear in mind that when I open the file with fopen, the function returns a file pointer. My pointer is the variable f. I can now use various functions to make this pointer point to various positions in the file. Moving a file pointer to a specified position is called seeking. And my code starts by using the fseek function to seek to the end of the file. I do this using the seek_end constant as the third argument. Now I can use the ftell function, and these are standard functions that you can use when you're processing files. I can use that function to find the position of the file pointer. This position is given in bytes, with 1 byte per character. So the position here tells me how many characters are in the file, and I assign that value to the size variable. Now I want to move the pointer back to the start of the file, and the rewind function does that. I then read the characters into a character array or buffer, that's B, and also I incidentally keep account of the characters in the file. The loop counter I counts through the characters that have been loaded one at a time. Now in addition, the items_read variable was initialized with the number of items, and here that's the number of bytes or characters that were loaded from the file. So, all being well, items_read and I should have the same values by the time this function has completed. And I can check that when I display them. And I do that in this line here. So, let's run it and see if it works as expected. And there are the results. It shows that I've got 14 lines, so that's the same results as I got when I used the file as a normal text file, counting the lines one by one, but this time I do it in a different way by looking for the new line character. And both the variable of I and the variable of items_read are the same value, that's 644, to show that 644 characters have been processed, 644 items, that's bytes or characters, were read. But before leaving this program, this line here needs some special attention. What exactly is going on when I call the malloc function and assign the results to the character array B? Now I'll look at that in more detail in the next video.